Okay, so we are on target 10B. We're talking about domain of a function in a real-world context. We'll also be touching on range a bit. Learning goals, I can express a domain as an, not in, as an inequality. Express the domain of a function in a real-world context. Find the domain and range of a function. Write the domain for a specific range of a graph and identify a correct response to a problem and defend my answer. All right, terms to know. So a lot of this is going to be reviewed. Domain, that's the input or the x values of a function. Range is the output or the y values of a function. Rate of change, that's the slope, the difference in y values over the difference in x values. That I just threw in there, but you should know that by now for certain. All right, first example, find the domain of the graph below, which is f of x equals negative x plus 1, with a range of negative 2 is less than or equal to y, which is less than or equal to 4. So basically, even if this line kept going, we're only looking at a range of negative 2 to 4. So what you're going to do, so even, like I said, even if it kept going on, in either direction, that's fine. What you're going to do is you're going to look at just the x values and that y values. And when you have a graph, the easiest thing to do is just draw lines from your range to those points on the graph. And then it's just a matter of taking these points, so this point right here where they cross and this point right here where they cross, and draw up or down or whatever to the x-axis so you can see what those values are. So draw it down. So we have a minimum of negative 3 and a maximum of positive 3. So we write it as the domain is negative 3, so x is greater than or equal to negative 3 and less than or equal to 3. Simple as that. Second example. Your cell phone plan charges you 25 cents for each text message you send. You save $100 from your paychecks every month to pay for your texting addition. So if the cost, C of t, is 0.25 t, and that t represents the number of texts you send per month, what's the domain of the function? So we've got the function right here. We've got the value of it. C of t equals 0.25 t. And what we're going to do is we're going to replace C of t because that's how much we have to spend. So that's the total cost that we can spend. So this right here matches up with the 100 up here. Okay, so we replace that, divide both sides by 0.25, and you get t equals 400. So you can send 400 texts, and we write the domain because we don't just say, okay, t equals 400. We write it like this because you can send less than 400 texts if you want. So 0 is less than or equal to t, which is less than or equal to 400. So you've got to make sure that you do this extra step to go from here to here. If you don't, it's not going to be right. Third example, Allstate Arena is capable of seating 15,800 people. Disney on Ice is coming to the Allstate Arena, and the amount of money that Disney on Ice brings in as revenue, which is R, is a function of the number of people, which is P, in attendance. So each ticket costs $45, and we need to find the domain and range of this. So we know that the domain is actually really easy to find because domain is the people. So domain is always going to be what's on this side with the coefficient. In this case, 45 because it's $45 per person. So the domain is going to be 0 to 15,800 because P is people and we can seat a max of 15,800 people. To find the range, though, we need to replace P with that because that's going to give us our upper end. Multiply those two together to get 711,000. So the domain, like I said, is P is less than or is greater than or equal to 0 and less than or equal to 15,800. The range will be R is greater than or equal to 0 and less than or equal to 711,000. So the domain represents the number of people that can be sat. We can sit anywhere between 0 to 15,800. The range is how much money we'll make, which is going to be anywhere between 0 and $711,000. Fourth example, write the domain for the interval of the graph with a positive linear rate of change. So you've got to pay attention. This says linear. So we're looking for a line because we have a couple spots where there's a positive rate of change, but we're looking for the linear one. So that's this right here. Okay? And that's between x is 0, which is right there, and 4, which is right there. So x is greater than or equal to 0 and less than or equal to 4. a positive nonlinear, so we're looking for something that's not a line now, rate of change, and that starts right here, and it continues on to 8, which is right there. So x is greater than or equal to 5, but less than or equal to 8. And then finally, a rate of change is 0, meaning the line is straight vertical, like that. And that is when x is greater than or equal to 4 and less than or equal to 5. All right, that should be a the. So the function p of t equals 15 times 1.40 to the x power represents the population growth of rabbits over time t. Emma and Mary are trying to determine when the population reaches 9,000. Mary says the answer can be 18.9 years, but Emma says it cannot be 18.9 years because it is not in the domain. Decide who is correct and justify your answer. Well, it very well could be 18.9 years, and it's a reasonable answer because it's positive. So Mary is correct because she gives an answer with a positive value. So if she gave an answer with a negative value, she would be incorrect. Since the domain Mary gives is a positive number, will represent a measure of time, her answer is reasonable because the domain representing time can only be positive. So basically, in a nutshell, because we're talking about something involving time here, it has to be positive. So if you ever saw anything where someone was trying to say it was negative, it can't be that. All right, so even though this one looked a little intimidating, there's no real math involved. You just have to basically say it's time, distance has to be positive. That's another example. So those are all things that you need to think about. Can the answer be positive? Can it be negative? And use that to justify your answer. And that's it for this particular target. So we are we're not quite halfway done yet, but we're moving along. And if you guys have any questions at all, just ask them in class. Take it